Hello friends, this is 7th part in the chapter Organic Chemistry, some basic principles and techniques from your first year chemistry syllabus. Until now we have studied the purification techniques. The last 6 online classes were dedicated for purification techniques in organic chemistry. Now we shall see some other techniques by which you can identify a given organic compound. Now in our bridge course classes we have told you that organic chemistry is a branch of chemistry which deals with the study of carbon and its compounds. In other words, it deals with the study of hydrocarbons and their derivatives. Now you may ask what hydrocarbons are. So you should be knowing that these are the compounds which contain carbon and hydrogen in them. So for those compounds which contain carbon and hydrogen, a separate branch was made. Now you know what hydrocarbons are, but what are derivatives of hydrocarbons? So if I am not wrong, I have also told you that the derivatives of hydrocarbons are those organic compounds in which one or more hydrogen atoms from a hydrocarbon are replaced by other atoms. From a given hydrocarbon, if you replace one hydrogen or more number of hydrogen and replace them with some other atoms, then such compounds obtained are called derivatives of hydrocarbons. So how do you say that a given compound is organic compound? Basically it should contain carbon and hydrogen in it. In addition to these, there are other elements also which will be or which might be present in the organic compound, such as nitrogen, such as oxygen, such as sulfur, halogens, phosphorus, etc. So if any organic compound is given to you and if you are asked to identify what it is, then the very first step in identification, as I have told you, is purification. You need to make sure that the compound given to you is purest. How do you check the purity? We have studied purification techniques in our last sessions. There were 5 techniques: sublimation, crystallization, distillation, then solvent extraction and chromatography. So based on the nature of the organic compound given to you, you will subject it to the respective purification technique and make sure that the compound available with you is purified and 100% pure. Once the purity is known, once you make sure that the compound is pure, then comes the second question: what is present in that compound? What is present in the organic compound which makes it to say that it is organic in nature? So the first thing is it should be containing carbon and hydrogen fixed. Then other elements presence can be checked. So the checking of elements in any given organic compound is its detection. So the second part of the chapter is detection of elements. Detection of elements in organic compounds. So any organic compound will obviously contain carbon and hydrogen in it. These two are fixed. In addition to these, in addition to carbon and hydrogen, you may have nitrogen, you may have sulfur, you may have halogens, oxygen, phosphorus, etc. Any of these can be, might be or may not be present in an organic compound, but these two are fixed. This is the reason why we say an organic compound is nothing but a hydrocarbon or a derivative of hydrocarbon. So when I say you need to detect elements, how do you detect? There are various tests for different elements. Each element can be identified for its presence by a number of tests. So let us begin first with carbon and hydrogen. So carbon, the first detection is detection of carbon and hydrogen. Carbon and hydrogen both are detected by one method. Means a single method is used to identify the presence of carbon and hydrogen. How is it detected? You see, in order to detect carbon and hydrogen in any organic compound, you need to have cuprous oxide with you. You need to have, or simply say copper oxide. You need to have copper oxide as the compound which helps us to identify whether a given compound is containing carbon and hydrogen. How? So for that you need to take two test tubes. The diagram is not there for your syllabus, it is only for the sake of understanding. You take two test tubes, both are to be hard glass test tubes because it requires continuous heating, and that glass should be such that it should withstand high temperatures and more heat. So for that reason we choose hard glass test tubes. So in the first test tube, which is a hard glass test tube, you should make sure that it is completely dry. When I say dry, there shouldn't be any traces of water in it. There shouldn't be any moisture present in the test tube. So make sure that the test tube is completely dry and hard in nature. Now in this test tube, you put your given organic compound. Say this much of organic compound is given to you. You add given organic compound. Now to this given organic compound, you add some amount of or calculated amount of copper oxide. You add calculated amount of copper oxide to it. So what did you take in the hard glass test tube? One was copper oxide and the other was your organic compound. Now what for are you testing this organic compound? To check the presence of carbon and hydrogen. So time being, you believe that this compound might contain carbon and hydrogen, and for that reason you are testing it with copper oxide. Then this test tube is containing now organic compound and copper oxide. Now in the other hard glass test tube, which is not used for heating, so you should take lime water. What do you need to take? You need to take lime water. What is lime water? Lime water is nothing but calcium hydroxide. It is nothing but calcium hydroxide. Once when this is done, you need to have a glass tube bent. You need to take a bent glass tube. How should it be bent? It should be bent in U-shaped. So you need to have a U-shaped glass tube. You need to have a U-shaped glass tube which should have these specified conditions. One, it should have a bulb. Bulb means a globular shape at the center of the glass tube. So you should have a bent U tube. You should have a bent U-shaped glass tube. Okay. Now this bent U-shaped glass tube should be having here, it should contain anhydrous copper sulfate. It should have anhydrous copper sulfate. Once this is done, then you close the mouths of both the test tubes. You close the mouth of both the test tubes. Before heating is done, make sure that the other end of the bent U tube is dipped inside the lime water. It is dipped inside the lime water. Now you heat the first test tube. You heat the first test tube. Now before heating, you need to remember that you will identify carbon and hydrogen. Always remember, carbon when heated in the presence of oxygen or in the presence of air gets converted to carbon dioxide. We say carbon dioxide is the oxidized product of carbon. Similarly, whenever hydrogen is burnt in presence of oxygen or air, it produces water. Therefore, water is the oxidized product of hydrogen. Keeping this in mind, always remember that whenever carbon is burnt in presence of oxygen, it will produce carbon dioxide. It will produce carbon dioxide. Similarly, if hydrogen is burnt in presence of oxygen, it will produce water. What will it produce? It will produce water. If this is known to you, then our work becomes easier. So you will now convert the carbon present in the organic compound to carbon dioxide, and similarly hydrogen present in the organic compound should get converted into water. Okay, the purpose of using copper oxide is it is an oxidizing agent. It oxidizes the other compound, it gives oxygen to the other compound. Now what is the other compound? Our organic compound. What is it containing? It is containing carbon and hydrogen. So when copper oxide gives oxygen to the carbon present in the organic compound, it will get converted into carbon dioxide. Similarly, hydrogen is present in the organic compound. Now copper oxide is giving oxygen to the hydrogen present in the organic compound. Therefore, that hydrogen will get converted into water. It will get converted into water. So if this is known, now when carbon dioxide is formed upon heating, in this, if carbon is present, it will get converted into carbon dioxide, and if hydrogen is present, it will get converted into water. Okay, it will get converted into water. How do you check the presence of carbon dioxide and water? Both will be in the form of vapors. Both will be in the form of vapors. So upon heating, the vapors of both carbon dioxide and water are liberated. So they cannot go outside from here, so they will travel from the U-tube only. They will travel from the U-tube only. So once water comes in contact with copper sulfate, what was there in the U-tube? In the bent U-shaped glass tube, there was anhydrous copper sulfate. Anhydrous copper sulfate is white in color. In chemistry, white refers to colorless. Our regular salt that we use in our house, we call that as colorless only. Basically, you might say it is white color, but it is colorless. According to chemists, white color is considered as colorless with respect to solids. Okay. So water, if it is present, when it comes in contact with copper sulfate, which was initially white, once when water comes and gets trapped in copper sulfate, then this copper sulfate will become copper sulfate pentahydrate. It will become copper sulfate pentahydrate, whose color will be blue. So a white colored salt changing its color to blue color, white colored salt getting changed to blue colored salt indicates the presence of water in the compound. If water is there, then hydrogen is present. So indirectly or directly, you are confirming the presence of hydrogen. How? You are converting hydrogen into water. How do you convert that hydrogen into water? By oxidizing the given organic compound with copper oxide. Water goes and reacts with anhydrous copper sulfate, which was white in color, and after getting reacted with water, it became white. Therefore, it confirms the presence of water, which confirms the presence of hydrogen. Then along with water vapors, even carbon dioxide vapors went outside. So these carbon dioxide vapors, while traveling, when they come in contact with this lime water, when carbon dioxide comes in contact with lime water, then what happens? Then you will have calcium carbonate and water formed again. This calcium carbonate gets precipitated. Remember, this downwards arrow indicates precipitate. It gets settled down. Now calcium carbonate is white. Calcium carbonate is white. Initially, lime water is colorless, and this calcium carbonate will appear milky. It is as good as converting water into milk. So you have transparent solution here. What is that? Lime water. It suddenly gets converted into cloudy, milky solution, which confirms the presence of carbon dioxide. Now, if this is clear, you might have these doubts. Sir, water and carbon dioxide both were liberated simultaneously. What if carbon dioxide comes and reacts with copper sulfate? One, it does not react. It does not react. Second, sir, what if H2O from here enters inside lime water? It makes no difference. Only the quantity will increase, but the color will not change. When water is added to calcium hydroxide, nothing happens. But when carbon dioxide enters into the lime water, it changes its color to milky, thereby confirming the presence of carbon dioxide, which confirms the presence of carbon present in an organic compound. So, for 2 marks, if they ask you how do you detect the presence of carbon and hydrogen in an organic compound, what will you say or what will you write? Beginning from here. Carbon and hydrogen present in the organic compound are oxidized to carbon dioxide and water respectively. The presence of carbon dioxide is detected. The presence of carbon dioxide is detected by passing the gas through lime water, which becomes milky. The presence of water vapors are brought into contact with anhydrous copper sulfate, which becomes blue due to the formation of copper sulfate pentahydrate. These two reactions confirm the presence of carbon and hydrogen in an organic compound. In this way, you can say that the compound is containing carbon and hydrogen. Okay, detection of carbon and hydrogen is this much. Then next we shall see other detections, detection of other elements excluding carbon and hydrogen. So the second detection is detection of nitrogen, sulfur and halogens, where X stands for chlorine, bromine and iodine. We generally do not detect fluorine. It's not that it cannot be detected, but for your syllabus only 3 elements are prescribed. What are those? Chlorine, bromine and iodine. Now, before we begin the detection of nitrogen, sulfur and halogens, now time being, forget that carbon and hydrogen's detection reagents should not be used here. Okay, there you used copper oxide. That part is over, so forget it. Now come back to detection of nitrogen, sulfur and halogens. All the three elements, they are identified by one method. They are identified by one method. That method is called Lensagne's method or Lensagne's test. Name is very good, Lensagne's method. Some books say G should be silent, so it could be Lensagne's test or Lensagne's method. So this fellow Lensagne, he devised a method to identify the presence of nitrogen, sulfur and halogens in any given organic compound. In order to identify, you need to prepare a solution. That solution was prepared by the same scientist, Lensagne. Therefore, we say you need to prepare Lensagne's extract, or it is also called sodium fusion extract. What is it used? It is used to check the presence of nitrogen, sulfur and halogens. How do you prepare? That is called sodium fusion extract, or simply said Lensagne's extract. How do you prepare sodium fusion extract? It could be a 1 mark question, it could be a 2 mark question. Now follow this very clearly or carefully. You take sodium metal. Where is sodium metal preserved? It is kept in kerosene, we all know that, or in any liquid like paraffin, any inert liquid. So you take out sodium from kerosene and dry it by pressing between the folds of filter paper. You remove all the traces of kerosene attached to it. Now cut sodium metal using a blade or a knife. To what size? To the size of a rice grain. Okay, a very small piece of sodium metal about the size of a rice grain is taken in an ignition tube. I'll tell you what test tube is. Say if this is the size of a test tube, imagine if this is the size of a test tube, then a sodium fusion tube is this small. Okay, it is so small. So this tube is called sodium fusion tube. It is called sodium fusion tube, or it is also called ignition tube. It is also called ignition tube. So what is done? A very small piece of sodium metal, about what size? About the size of rice grain, is made free from kerosene and taken in sodium fusion tube, or simply called ignition tube. Then this sodium fusion tube is heated. It is heated. It is heated slowly, because remember, sodium is a highly reactive metal. For that reason, you need to heat sodium fusion tube very slowly. Till when should you heat? Until all the traces of the impurities present on the sodium metal gets evaporated. Okay, once when this is done, then you add a pinch of organic compound. If the compound given to you is solid, then add a pinch of it to the sodium fusion tube, or else if the compound given to you is liquid in nature, then you need to add a drop of the organic compound. So either a pinch of the organic compound or a drop of the organic compound is added over this. A pinch of the organic compound is added to the, I will label them, this is sodium metal and this is our organic compound. A pinch of the organic compound is added to the sodium fusion tube or ignition tube and again heated. What is heated? Ignition tube or sodium fusion tube is again heated. This time you need to heat slowly until the reaction between the organic compound and the sodium metal gets completed. Now how do I know whether the reaction is complete or not? When you begin to heat the sodium fusion tube initially, before adding the organic compound, you will make sure, you will observe that some vapors begin to emanate or liberate from the sides of the sodium metal. This indicates that the impurities are going outside. When you add organic compound, you may see some hissing sound, or else both metal and the organic compound begin to react with each other. You will be able to visualize this. So when the reaction between both the organic compound and the sodium metal completes, till then you need to heat slowly. Now as soon as the reaction between the metal and the organic compound completes, you heat it strongly. What do you heat strongly? You need to heat the sodium fusion tube or ignition tube strongly until this sodium fusion tube becomes red hot. The sodium fusion tube, which is obviously made up of glass, it should become red hot. Once it becomes red hot, then immediately you need to drop this sodium fusion tube into a china dish. You need to drop this into a china dish which is containing 5 to 10 ml of distilled water, kept already for boiling. It is already kept for boiling. Okay, so what did you do? You first heated sodium metal, then you heated organic compound with sodium metal. Till the reaction completes, you heated it slowly. After that, once the reaction between the organic compound and the sodium metal gets completed, you heat vigorously. You heat the ignition tube strongly until it becomes reddish hot, and the red hot ignition tube is immediately plunged or dropped into a china dish, which should already contain 5 to 10 ml of distilled water, which has been kept for boiling. Means simultaneously, while you are carrying out this test, while you are heating sodium fusion tube, on the other side you should keep some water for boiling in a china dish. So when you drop the glass tube, which glass tube? Sodium fusion tube or ignition tube containing the organic compound and sodium metal into the china dish, the glass breaks and the contents present inside the glass tube will come outside and mix with water. If the glass does not break, you can break it with a glass rod. Okay, because it is hot, red hot, and dropped in water, it will obviously break. It will break. Upon breaking, the contents present inside will get transferred to the water. Then you heat this solution for a while again. And filter. The filtrate that you remove, the filtrate that you take out is called, or the distillate that you take out, not distillate, filtrate only, the filtrate that you take out is called sodium fusion extract, because you fused the sodium metal with the organic compound, therefore it is called sodium fusion extract, or it is simply called Lessagnese extract. Now what is Lessagnese extract? It is an extract prepared by using sodium metal and the organic compound. What does it contain? It will contain either nitrogen or sulfur or halogens or any two of them or all the three of them. If your organic compound is containing nitrogen, sulfur and halogens, then you need to prepare sodium fusion extract, using which you will identify the three elements nitrogen, sulfur and halogens. So what have we done till now? We have prepared only sodium fusion extract. You did not detect any of the elements until now. Okay. Now once your sodium fusion extract preparation is done, when sodium fusion extract or Lessagnese extract is done, then comes the exact Lessagnese test. I'll briefly tell you how to prepare sodium fusion extract once again. Follow this clearly, and if you asked for 2 marks, you can write this. A very small piece of sodium metal about the size of rice grain is taken into a sodium fusion tube. It is taken into a sodium fusion tube and heated until all the impurities are gone, and then a pinch or a drop of the organic compound is added over it, again heated slowly till the reaction between the organic compound and the sodium metal completes, and then strongly till the ignition tube becomes red hot. The reddish hot ignition tube or sodium fusion tube is immediately dropped into a china dish containing 5 to 10 ml of boiling distilled water. The contents of the ignition tube are transferred into the distilled water. These contents are boiled for some more time and is filtered. The filtrate or the extract is called sodium fusion extract, used to detect the presence of nitrogen, sulfur and halogens in any organic compound. This is how you prepare sodium fusion extract or Lessagnese extract. Using this you will identify nitrogen, sulfur and halogen. So let us now first test only nitrogen. Let us see how nitrogen is done. Now before I explain how nitrogen is tested, you need to know what happens when this test is done. If your organic compound is containing nitrogen, containing nitrogen, then it will react with the sodium metal. It will react with the sodium metal along with carbon, and it will get converted into sodium cyanide. It will get converted into sodium cyanide. What got converted into sodium cyanide? The nitrogen present in the organic compound has now got converted into sodium cyanide. Where? In sodium fusion tube. If it was containing sulfur, if your organic compound is containing sulfur in it, then when it reacts with sodium metal, it will get converted into sodium sulfide. It will get converted into sodium sulfide. Similarly, if it was containing halogens, it could be chlorine, bromine or iodine, then when it reacts with the sodium, it will get converted into sodium halide. Keep these in mind. And now for detection of nitrogen, which will you select? you will select the first one because we are identifying nitrogen. So time being you assume that nitrogen is in the form of sodium cyanide. So to detect nitrogen's presence in the organic compound, you take that prepared Lasagne's extract. From that you take about 2 ml of sodium fusion extract. You take 2 ml of sodium fusion extract, then add freshly prepared ferrous sulfate solution. Add freshly prepared ferrous sulfate solution to it. Once when you add freshly prepared ferrous sulfate solution to it, then you need to boil. You need to boil this mixture. After boiling, cool. After boiling, you cool the solution, and upon cooling, you acidify that given mixture with concentrated sulfuric acid. You acidify the mixture with concentrated sulfuric acid, 1 or 2 drops of sulfuric acid, and then add few drops of ferric chloride solution. You then add few drops of ferric chloride solution. Upon doing all of this, you will get this color. You will get Prussian or Prussian, not Persian, Prussian or Prussian blue colored solution is obtained. This indicates the presence of nitrogen. It is easier to write in this form, isn't it? What do you need to do? You take 2 ml of Lasagne's extract or sodium fusion extract, add ferrous sulfate, boil, cool, then add 2 to 3 drops of sulfuric acid, followed by adding ferric chloride solution to it. It will give you what color? It will give you Prussian blue color solution. Some of you might ask, sir, what is Prussian? Blue we know, but what is Prussian? If you have seen peacock color, peacock feathers, if you know that color, it is Prussian blue color. If you are not able to get Prussian blue color, then at least you should get the green color that you see in the feathers of peacock. At least that green color or the blue color seen in peacock's feather, it is called Prussian blue color. If that colored solution is obtained in the test tube, it indicates nitrogen. If any other color is obtained, it is not nitrogen. Fine. Okay. This is the general principle on how detection of nitrogen works. What are the exact reactions that take place inside? So what did you do first? You had your nitrogen in the form of sodium cyanide. True. So in the first step you reacted it with ferrous sulfate. Upon reacting with ferrous sulfate, what happens? The nitrogen present in your organic compound gets converted into ferrous cyanide. It gets converted into ferrous cyanide and sodium sulfate is formed. What happened in the first reaction? Nitrogen, which was in the form of cyanide, now got converted into ferrous cyanide. This happens in the first step. Okay. Now this ferrous cyanide again reacts with more of sodium cyanide present in the test tube. It reacts with more of the Lasagne's extract, which is sodium cyanide, and it gets converted into sodium ferrocyanide. It gets converted into sodium ferrocyanide. How do you balance this? By writing 4 here. So ferrous cyanide, which was formed once when Lasagne's extract and ferrous sulfate were reacted. So this ferrous cyanide reacts with more of sodium cyanide and gets converted into sodium ferrocyanide. So to this sodium ferrocyanide you will cool and then you will add sulfuric acid. Sulfuric acid does not take part in the exact reaction, it is for acidification. So after reacting with sulfuric acid you will add ferric chloride. So next you will add to sodium ferrocyanide you will add ferric chloride. You will add ferric chloride. Upon addition of ferric chloride, what will happen? You will get this Fe4 FeCN6. It is called ferric ferrocyanide plus NaCl. This is 12. So I'll write here 3. Okay. So you will get ferric ferrocyanide. The color of ferric ferrocyanide is Prussian blue. So this is the exact chemistry that happens inside the test tube. First, you will react Lysagnes extract with ferrous sulfate. You will boil, cool, then acidify it with sulfuric acid. Lastly, you will add ferric chloride. Upon adding ferric chloride, the nitrogen from here, from cyanide, from sodium cyanide it became ferrous cyanide. Then from ferrous cyanide it became sodium ferrocyanide. Where is our nitrogen? Here. So this sodium ferrocyanide now became ferric ferrocyanide. Ferric ferrocyanide is a complex salt which gives Prussian blue or peacock blue color in the test tube. If you get this color, then it indicates the presence of nitrogen, otherwise no. So how do you detect the presence of nitrogen? I'll begin with preparation of Lysagnes extract. Small piece of sodium metal is taken in sodium fusion tube, heated, then a pinch of organic compound is added, heated slowly. After the reaction completes, again heated strongly till red hot. This red hot ignition tube or sodium fusion tube is dropped in a china dish containing 5 to 10 ml of boiling distilled water. The contents are transferred to water. Again it is filtered. The filtrate is called sodium fusion extract. From that sodium fusion extract you take out 2 ml. You have prepared 5 to 10 ml, no? So you take out 2 ml of sodium fusion extract. To this you add freshly prepared saturated, I forgot to tell you, this freshly prepared saturated ferrous sulfate solution should be added. Saturated means it is a solution in which the concentration of ferrous sulfate is more, concentration of water is less. If you are not able to understand, how do you prepare? To a test tube containing water, 3/4 of water, you add some ferrous sulfate, shake well, add some more, shake well. You keep on doing this until ferrous sulfate does not dissolve in water. That solution is called saturated solution. Make sure that ferrous sulfate should be prepared freshly. So to the 2 ml of sodium fusion extract or Lysagnes extract, add freshly prepared saturated ferrous sulfate solution. You boil the solution, cool. Upon cooling, acidify it with sulfuric acid and then add 2 to 3 drops of ferric chloride solution to it. Upon adding ferric chloride, the color will become greenish or Prussian blue color, indicating the presence of nitrogen in an organic compound. Based on this, you can also expect competitive exam questions like, what is the chemical compound which gives Prussian blue color in detection of nitrogen? It is ferric ferrocyanide. If the name is not given, then they may give you different formula, whether it is this compound or this compound or this compound. So you should know Fe4 FeCN6. Ferric ferrocyanide is the complex formed which is responsible for giving Prussian blue color. So today we have learnt detection of carbon, hydrogen and nitrogen. There are many more detections. The next is sulfur and halogens. We shall see how sulfur and halogens are detected in our next session. Thank you.